Welcome back. It's time to start on section 3.4, properties of logarithmic functions. You'll need a couple of things for this video. First of all, you need this worksheet entitled Deriving the Logarithmic Property, section 3.4. And then you will also need your note packet, and we're on page 22 of that. But we are going to start over here on the separate worksheet. So get that out and ready to go, and we'll get started. So we're going to learn 4 properties today of logarithmic functions. You did these last year in Algebra 2, I know. However, we are going to derive them here so you can see why it is that they're true and just review them a little bit. So first of all, we're going to do the power property. As you can see up here, it says let's review the conversion between logarithms and exponentials. Right here, log base b of x equals a is equivalent to the expression b to the a power is equal to x. And so, we've been working with that over the last couple of sections, so hopefully you're very familiar with that. These steps here are going to guide us through deriving the power property, which again, we have used the power property in this chapter even, but now we're going to derive it. So step 1 says raise both sides of the exponential equation to the nth power. This one over here on the right is the exponential equation. So I'm just going to raise both sides to the n. Now it looks like that. Then convert that into logarithmic form. So that would be log base b of x to the n equals a times n. So I made this the base of the logarithm, and then this is the exponent, and remember log means exponent. So the log base b of x to the n equals an. Step 3, now multiply both sides of the original log equation in the box above by n. So here's my original log equation. I'm just going to multiply both sides by n. N times log base b of x equals a times n. And then I'll just use substitution, or the transitive property, you can think of it that way. Notice n times log base b of x is equal to an, and also up here log base b of x to the n is equal to an, so therefore these must be equal to each other. So log base b of x to the n must be equal to n times log base b of x. And that's our power property. Whenever you have the log of something to a power, you can take that exponent and move it out front and make it the coefficient, and those are equivalent. Our next property that we're going to talk about is the change of base. And for that, we're using those same 2 equations that you have at the top of your page. I just recopied them here so I could see them on my screen. It says select a new base, typically 10 or e, and take the logarithm of both sides of the exponential equation with your chosen base. I'm going to use base 10 here. So I'm going to take this exponential and just take the log of both sides. And we can do that and create an equivalent expression. Step 2, use the power property of logs to expand the left side. The power property is what we just proved, that if you have the log of something to a power, you can make that power into the coefficient. Solve for a. So I would need to divide both sides by log b in order to make that happen. And then it says use the substitution property of equality, set the original log equation up here equal to this expression. So a is equal to both of these, and so these are equal to one another. So we would just have log base b of x equals the log of x over the log of b. Notice what we have done here is we had something in base b and we changed it to base 10. Now, there's nothing magical about changing it to base 10. We could have chosen whatever base we wanted. So up here on this original step, if I had taken the natural log of both sides, try that again, natural log of b to the a equals the natural log of x, then we would have had a times the natural log of b equals the natural log of x. Then we would have had a equals the natural log of x over the natural log of b. So then log base b of x would be equal to the natural log of x over the natural log of b. And you can change it to whatever base you want. Let's say for some weird reason you wanted to change it into base 17. Then you would have log base 17 of x over log base 17 of b. These are all equivalent. It does not matter what base you're wanting to change it to. This is the format in which you do that. Notice that there's no such thing as saying, oh, I'm just going to cancel the logs here and just make it x over b. Can't do that. These are not factors. These are functions. So you cannot just say, oh, I'm going to cancel those logs. That is not allowed. Let's undo that. Okay, so those are the first two properties. Now let's go over to the backside there and look at the last two. The first one is the product property, and for this one we start with two different sets of log and equivalent exponential expressions. Log base b of x is m is equivalent to b to the m equals x, and log base b of y equals n is equivalent to b to the n equals y. And the first thing it asks us to do here is use the multiplication property of equality to multiply these two exponential expressions here, or equations. So if I multiply the two expressions on the left, that'll equal the product of the two expressions on the right. So I'll have b to the m times b to the n equals x times y. And we need to simplify that result. So we know over here on the left-hand side, when you're multiplying two expressions with the same base, you add the exponents. So that would give us b to the m plus n equals x times y. Step 2, convert that simplified answer to log form. Log base b of xy equals m plus n. And then step 3, use the addition property of equality to add the log equations. So we multiplied the exponential equations. We're going to add these log equations here. So if I add the two expressions on the left, log base b of x plus log base b of y, that should be equal to the sum of the two expressions on the right, m plus n. Notice again, just like on the first two, now we can use substitution because both of these are equal to m plus n, so they must be equal to one another. Log base b of xy equals log base b of x plus log base b of y. There's your product property. When you're taking the log of a product, you can break it up into the sum of two logs as you see there. Then similarly, there's a quotient property. So let's quickly derive that one. It works in much the same way, except now instead of multiplying these two, we're going to be dividing them. So we'll have b to the m divided by b to the n equals x divided by y. And then we simplify that. When you're dividing two expressions with the same base, you can subtract the exponents, like so. Convert that into log form. Log base b of x over y equals m minus n. Now, we're going to go back up here to these two log equations and we're going to subtract those. Log base b of x minus log base b of y equals m minus n. And then, since both of these are equal to m minus n, they'll be equal to one another. So we can use substitution and say that log base b of x over y is equal to log base b of x minus log base b of y, and there's our quotient property. All right, let's go over to our note packet then and just fill these in. Hopefully that gives you an idea of why these are true. You have a spot on your notes in order to fill in the rules. I used some different letters here rather than x and y, but you've got the product rule or the product property as I have on your sheet there. Same thing. Log base b of m times n is log base b of m plus log base b of n. Quotient rule, the log of the quotient is the difference of the logs. The power rule, you can take that exponent and make it into a coefficient, and those two are equivalent to one another. Notice that these rules only apply if, b, m, and n are positive real numbers. Remember, you can't have a negative base. You can't have negative numbers that you're taking the log of. Also, the base can't be 1. P can be any real number, this exponent here, but there are restrictions on the values of these. And then you on yours also have a spot for the change of base formula, so if you want to put that in there, you can. If you have log base b of x, that is log base a of x over log base a of y. And you can, not y, silly, that's not right. Let's see here, get rid of that. Okay, so it should be log base b of x over log base b of a. There we go. No. All right. Let's try this again. I'm trying to change the base, so I want a different base than what I have here. Okay, so that is log base a of x over log base a of b. There we go. Now I've got it right. I didn't want to have to erase that and start over. I've already had to start over once on this particular video because my sound wasn't working. So anyway, more than you need to know. But there are our properties that we're going to be using in this chapter. So we'll stop this video right here and pick up with the next one. Have a good one.